All right, so now we're going on to the mole part of stoichiometry. And no, I'm not talking about the rodent. So make sure you do your travelogue 3, the first part. All right, what the heck is a mole? So this is the unit that we're going to use for very large numbers for very small structures. In this case, we're going to go for Avogadro's number. 1 mole, the Latin word mole means a mass. So a mole is a mass of an element, right? So it's the amount, mass, or volume of a material that contains Avogadro's number. What the heck is Avogadro's number? That is the number of carbon atoms in 12 grams of carbon-12. And that amount is 6.02 times 10 to the 23rd. A number you're going to have to memorize. So just get used to 6.02 times 10 to the 23rd. Memorize it. Okay, so this also refers to a fixed number of any type of particle. It could be atoms, molecules, in this case, toasters. It's all 6.02 times 10 to the 23rd. Anytime I use mole, that's what you're going to be referring to. Okay, so now we have atomic and molecular weights. So atomic mass scale. So this is all based upon carbon-12 isotope. Remember, isotopes are just a different amount of neutrons in an atom or in an element. Carbon, there's carbon-12, carbon-13, carbon-14, but the most common that we find is carbon-12. Okay, so the carbon-12 isotope. This isotope is assigned a mass of exactly 12 atomic mass units, AMUs, and the masses of all other atoms are given relative to this standard. So it's the base of like everything. So 1 AMU is 1.66054 times to the negative 24th grams, or 1 gram is worth 6.02 times 10 to the 23rd AMU. We're not going to use the AMUs. Well, we're going to use the AMUs, but we're going to stick to the moles, okay? So most elements in nature exist as a mixture of isotopes, like we've seen. And how we see this is when we went and did the atomic mass, weight, the AW. That is the weighted average. You're timesing the weight, like 12 carbon, 13 carbon, 14 carbon. You're going to times it by the percent you see in nature, and then you're going to add all of that up, and then it'll give you the average atomic mass. Okay, so now we have these things called molecular weights. So you've got formula weights. This is the sum of the atomic weights of each atom in a chemical formula. Okay, so how do we figure this out? We've got sodium nitride, and when you have this, you have the nice little formula. This formula, gives 3 nitrogens and 1 sodium, right? So all you have to do is take the number of the elements and times it by the weight of the element. For instance, nitrogen has a weight of 14, according to your reference table. So you're going to do 3, because there's 3 here, right here. There's 3 nitrogens, so 3 times 14. We have 1 sodium, so 1 times 23. You add them all up, and it gives you an AMU, or gram, in this case AMU, of 65 AMU for a sodium azide or a sodium nitride. Then you've got molecular weight. This is the sum of atomic weights of each atom in its molecular formula. So chemical formula, think of like ionic. And then molecular is when you see molecules. Well, what gives you molecules? That would be covalent. So in this, we have diborane, or diboron hex hydride. So looking at this, we've got 2 borons and 6 hydrogens. So you're going to times that by their weight. Ideally, I would probably stick to the ones. I would round up to the ones. So it'd be 2 times 11, 6 times 1. You add them up, and you should get roughly 28 AMU diborane. Okay? Is there a difference between molecular and formula weights? How we figure this out? No. Ionic compounds with extended arrays have no well-defined molecules, so they can't be molecular formulas. So we use the formula weights. Remember, formula, ionic, molecular, molecules, which is covalent. There is no real difference. You use the same equation to figure out each. Okay. So this can also give us the gram molecular or gram formula weights. To do this, you figure out the mass of 1 mole of a substance, 1 mass of 1 AMU, right? 1 mole. So all you have to do is either the molecular or formula weights to get you the grams. Instead of AMUs, you're just going to plug in grams. It's 1 gram per mole, right? So if I've got phosphorus decaoxide, you're going to have 4 times 31. That's how much phosphorus weighs, and 10 times 16. Add them all up, and this would equal 284 grams per mole of phosphorus decaoxide. And then you've got bromine chloride, and 1 bromine is 80, chloride is 35.5 or 36. You times them, add them up, you should get about 116 grams per mole. Now I have another ionic compound, but it has the polyatomic ion. All you have to do is add everything up. So we've got 1 calcium, 1 and then looking at this 2 means everything there is multiplied by 2. So there's 2 nitrogens and 6 oxygens. And all you have to do is add them up. You should get about 164 grams per mole of calcium nitrate. All right. So in these exercises, you can see all you have to do, the gram molecular mass, gram formula mass, you're going to add everything up. You should get 180 nitrogen 5 oxide. So remember that 5 tells you the charge for the nitrogen. So if the nitrogen has a plus 5, oxygen minus 2, it's going to look like N2O5. N2O5, yes. And then, so there's 2 nitrogens, 2 times 14, oxygens, 5 times 16. You multiply it out, you should get 28 plus 80, 108 grams. All right, carbon dioxide, CO2. Again, you use the same formula. You should get 42 grams of carbon dioxide. So that was the gram molecular mass. Now I just want to do the molar mass of sodium carbonate. All you have to do, 2 times that, 1 times the carbon, 3 times the oxygen. You multiply it out, add it all together, 106 grams per sodium carbonate. Magnesium hydride or hydroxide. Magnesium has a plus 2 charge. Hydroxide has a 0, or sorry, not a 0 charge, a minus 1 charge. You should have this because the 2 gets crossed over. Then you're just going to multiply it out. 1 magnesium, 2 oxygen, 2 hydrogen. Add it all up. You should get 62 grams per magnesium hydroxide. Is there any difference in how these are calculated? Again, no difference whatsoever. So when I say gram formula mass, gram molecular mass, the molar mass, it's all going to be the same, just different ways to say it. Okay. So this is the end of this section. If you have any questions, please don't hesitate to ask. And I hope you guys have a great day.